All right, so now we're going to go through some examples of this process using the problems in the book that you're going to be assigned for homework. So chapter 3, page 162 are where these are at. We're going to start with number 8. Number 8 just says find dy dx. Here's our function x plus sine y equals xy. So the reason we know we're going to use this process of implicit differentiation is we see x's and y's, it's not solved for y, and it would not be easy to solve for y. In fact, it's quite possible that it would be impossible to solve for y in this equation. All right, so here's what we do. We do implicit differentiation. It goes like this. Step 1, take the derivative with respect to x on both sides. So that's step 1. We do derivative with respect to x on both sides. All right, so what that looks like is when I do a derivative of x with respect to x, that's no problem. We already know that's 1. All right, but when I do, so the short way to sort of, have this as a technique is to say whenever I do a derivative of something with a y, it's going to pick up a dy dx. When I do derivative things with x, it does not pick up a dy dx. That's the whole technique. All right. What's really going on calculus-wise is that the y of x is really an inside function, and you're doing chain rule. But you don't need to think about that. You just say, I'm doing derivative of a function in y with respect to x. It's going to pick up dy dx as a tag. All right. And then over here, now this is a good example of a pretty tricky one because over here you have a product, f times g. All right. So that means we have to use the product rule, f prime g plus f g prime. And we're going to have to be really careful about when do we pick up a dy dx and when do we not pick up a dy dx. The most popular question on this. So what you want to focus on is if I'm doing a derivative of a function with x, I don't have dy dx. If I have g and then it's still g, in other words, I did not do a derivative, no dy dx. The only time you're going to put on a dy dx is if you have a function in y and you're doing the derivative. All right, that's what you want to do. If I'm doing a derivative of a function in y, part by part on this. So when I do f prime, that's a derivative, but it's x, so no dy dx. This one's g, it's y, okay, but I'm not doing a derivative. This is g, there's no g prime. It's not a derivative, so no dy dx. All right, next one, I have f. So this is an x, I'm just copying. It's not a derivative, and it's not y. 2 reasons not to put a dy dx. But then when I do g to g prime, that's a derivative. This is g prime, it's a derivative. All right, and it's a function in y. So the derivative of y is 1, and then because it's a derivative of a function in y, I pick up a dy dx. All right, so that's how that can get tricky. Now I'm just gonna rewrite this a little bit, make it a little cleaner. So I have 1 plus sine y dy dx plus y, equals y plus x dy dx. And the more you practice this, you're gonna get a lot of chances to get good at this. And the more you do it, the more you'll get these pretty quickly. All right, so now the next step is that step 2, everything that has a dy dx is going to go to the left, and everything that does not have dy dx is going to go to the right. All right, this is a mathematical symbol for not. That's in our list of symbols that I gave you on the very first day. Not dy dx is going to the right. Okay, so by the way, the left and right are of course arbitrary here. I just like to put the dy dx's on the left and the non-dy dx's on the right, but of course you could do it the other way and it would work fine. Okay, so the x dy dx, that's a dy dx, it needs to go to the left. Negative x dy dx. So because I'm bringing across the equal sign, I got to change sign. The 1 is not a dy dx, so it's got to go over there to the right. Changing sign because I'm crossing the equal sign. Okay, the sine y is where it's supposed to be. It's a dy dx, so it stays on the left. The y is not a dy dx, so it's where it's supposed to be. It's on the right. All right, so all I've done here is taken the x dy dx, that's a dy dx, and I want to move it left. And I've taken the 1 that's not a dy dx, and let's move that over to the right. Everything else stayed where it is. Okay, now the next step that we did not have in our first example, but you will often have, is I have a bunch of terms over here with dy dx in them. Maybe I have 3. In this case, I have 2. All right. However many terms with dy dx, you have to factor that out. So we're going to factor out the dy dx. All right, so what that looks like is this dy dx, I'm going to bring it out like it's a factor because it is. All right, and then what I have left inside, negative x plus sine y. Right, so that's just factoring out the dy dx. If you notice, if you distribute it back, dy dx times that, dy dx times that, we get the same thing we had. The y minus 1 is going to stay where it is. Okay, and step 4 is divide. All right, so you divide by everything that's not dy dx. So we're going to divide this side by negative x plus sine y. We're going to divide this side by negative x plus sine y. And we get dy dx, because these guys cancel out, equals y minus 1 over negative x plus sine y. And that is it. That is the 4-step procedure for doing implicit differentiation, which you will get to practice amply. We will look at 2 more examples in the videos to come.